So we're going to move to the second part of our gathering, in which we are going to actually, again, we don't have any format or any agenda for this part. I very briefly introduce the panelists of this part. So we have, of course, Josh, and then we have.
Did Javier and Jing join us yet?
Yes, I can see them actually.
Yeah, I'm here.
Okay, great. Solid.
So we have three other group members, former group members, who are joining us. Let me start with Javier and Steven, who are currently working in industry in the Boston area, if I'm not mistaken, if they haven't moved recently in the last couple of months.
I'm still in Boston.
You're still in Boston, Javier?
Yeah.
Yes,
for a while.
They can tell us actually what is happening on the industry side. If you have any questions about them. And Jing, who did a postdoc in Chicago before joining the faculty in Mississippi. And of course, Josh himself was kind of a hybrid, going to semi-industry to national labs and coming back to academia. So we have these four group members, former group members, who with different actually experiences in terms of finding careers and establishing themselves. So again, I can just open it. Maybe, I don't know, maybe you guys can each.
I mean, yeah, the way I was figuring this is like we'd all introduce ourselves for about 5 minutes and detail the career paths that we took after leaving the group, and then go on from there. So do we have any volunteers? Because I've been speaking for a while.
I can start if you want.
Go ahead. Sure.
Okay, my name is Javier. I was in a math group from 2010 to 2016, I think. And I moved to Boston in 2016 after graduation for a job. So I started working at a smallish biotech company called Boston Biomedical that now doesn't exist anymore. And then I moved to another company, Wuxi Nextcode. I was doing more of like kind of machine learning stuff there. And it also doesn't exist anymore. They changed their name. And they actually had some issues with Marco Rubio, the senator from Florida. But anyways, and then I ended up in Merck. So I work in the Boston side of Merck. I've been there for over 2 years now. It's in the Longwood area, so it's surrounded by Harvard Medical School and the Fenway Park where the Red Sox play. And yeah, so I guess overall I've been like 4.5 years in the Boston area, bouncing from different companies. Yep, so that's what I'm doing.
So can you actually tell us, how did you find the job there, Javier? So that's one thing I would like to ask everyone, maybe to just briefly mention. How did you end up in the industry?
Right. So it took a lot of effort, mostly a lot of. So the worst part is, okay, so the first thing I will say is that having a LinkedIn profile helps a lot, because I think every, aspect of hiring or recruitment or finding candidates or everything, it's mostly done through LinkedIn. And even if you go to a company's website, they have job openings, I think everything is sourced to LinkedIn anyway. So that's the thing that helped me a lot. The worst part is that if you apply to 100 jobs, you're probably gonna get a couple of interviews, and a lot of them, they just ghost you. So they do this thing where they don't write back anything. You never hear back from them. And so, one thing you learn is that it takes about 2 weeks to hear back from a place. If you don't hear back in 2 weeks, then just move on and find another opportunity. But yeah, I guess I started my search through LinkedIn, and that's how I've been finding different opportunities around. I get a lot of recruitment emails from people in the area, like, are you interested in this position or this other position, through LinkedIn. So I think that's the biggest, basically social media, I guess,
I see.
Yeah.
See. Interesting. Jing, you want to go next?
Yeah, sure. Hi, Matt. Hi, everyone. Yeah. I'm Jing Li. I was in Emma's lab from 2008 to 2015. Actually, I received my PhD in 2014 but I stayed in the lab for 1 more year because my daughter was born in Champaign. Then I moved to Chicago. I joined Vermaas' lab at the University of Chicago. I had 5 years postdoc in his lab. Then I tried to apply positions in academia. I tried 2 years. In last March, I received an offer from University of Mississippi before the pandemic hit the US. And I had discussion with Ahmad, and I really thank his suggestion. I accept this offer, and then I joined University of Mississippi School of Pharmacy in last summer. Now I'm the brand new assistant professor here. Yeah, that's it.
So what do you think was most important, Jing? Again, I'm going to come back to the other panelists, asking them the same question. And everybody feel free, please, to ask questions, whatever questions you might have. So what was very important for you to find a job? What was the most important factor? What do you recommend to students to do to have an easier time or less difficult time finding a job in academia, Jing?
I think I think the first thing is still the research area. I have to say that make a big difference. Mm-hmm. Like for our like computational chemistry, molecular dynamic simulations, yes, we have many opportunities from biochemistry, chemistry, physics, chemical engineering, and like me, now I'm in the School of Pharmacy. There are many openings for us, but there are also much hot areas like genetics or machine learning. So I mean, research area make a big difference. But the next thing is, I think it's still you. It's about your interest. If you are really enjoying the research in academia, you like to do research following your own interest, I think you should at least try to apply positions in academia, because that's the part you are really enjoying. At the same time, I think another thing I'd like to mention is now it's even more competitive after the pandemic, because I paid attention to the openings in last fall for the applications in academia. Each cycle is like starts from the early September. You see a lot of advertisement openings, so you can pay attention to the advertisements. In last fall, I checked it, and I also have several friends who are still in the job market. The situation is there are much less openings compared with the 2 years I tried. So I would expect this fall it would be even more competitive, because there are a lot of candidates are still in the job market. So this is what you need to pay attention.
I see. I was hoping to hear about publications and how important they are, because that's the thing I advertise all the time to the students. But yeah, sure.
Publications also make a big difference. I think Josh might give you a much better example for this point of view.
I mean, so all right. Like, sorry, Stephen, I'm going to jump in here. Like, the one thing I noticed is that newly hired assistant professors are often right around 100 citations per year. Now, there are a lot of ways you can get to 100 citations per year. You can have like a couple of Nature papers, or you can have a broad swath of good science that gets cited. There are going to be a couple of them, like if you paid attention to my talk, like the stuff I was citing, some of them are in PNAS, some of them are in like an ACS journal that's reasonable but not spectacular. But like, you need a lot of publications. There's like no two ways around it in order to get a job in academia, especially coming from a computational side of things, because we know that you can't explain away like long bouts of non-productivity. Like if I look at an experimental candidate that doesn't have a paper or took a couple of years to get a paper out, like that's normal. Stuff can go wrong. Even our bad or even our incorrect or even the science that doesn't work the way we expect it to is a result that we can publish. So there's no
computationally.
Yeah, like computationally, stuff that doesn't work is still a publishable result, and it should be published. And you should get on a mod for not reading your papers.
You want to start?
Okay.
Okay, let's move on to Stephen.
Yeah. So now getting back to like how I found my positions. All right. So my postdoc, that came from one of the folks I worked on an internship with in the national labs. So unlike in industry, which works through LinkedIn, or academia, where it's like publications and reasonably merit-based hiring policies, the national labs, for better or for worse, depends on, do they know you? Yeah. So my position at the national labs are like, oh yeah, we'll totally hire this person for a postdoc, and we will work with you because we know you already. It can be difficult to get your foot in the door to work with people if you don't already have an existing relationship. That was also how I got my position at Oak Ridge. Like they had already been reaching out of like, hey, when you are ready to leave NREL, we want to have a talk because we know you do good work and we know you have the right background for what we need to do. Unfortunately, the national labs are also a little bit less flexible. And one of the reasons I left is because my wife couldn't find a job there. They're often in places that are less than ideal for two-body problem solutions. Like unlike the Boston area where it just kind of falls out of a tree, or academic positions where if you are a good enough candidate, they will make it work. And then so kind of, let's see, this would have been fall of 2019. Yes, fall of 2019 is when I went on the academic job market, same year as Jing. You write a lot of applications. I think I wrote 80 of them. That may have been excessive, but you have to kind of cast your net widely because you don't necessarily know who is going to see enough in you to, first off, give you a phone interview. Hopefully you don't bomb those. So then they'll give you an on-site interview. And then even for the on-site interviews, there are several folks interviewing for the position, and some of them, they might just be a better fit for the department. So for instance, one of the places I interviewed for last year was Auburn in the physics department. And one of our other friends is now taking that position because he was a better fit for the department. Great. So like that's why, even though it sounds really scary of you applied to 80 different places, that's kind of what it took to get a job offer that you are happy with to come forward. So for me, I interviewed at West Point. I probably was not the best fit for West Point. I interviewed at WashU. WashU had COVID-related hiring problems, so they couldn't make an offer. I applied to Southern Illinois University at Edwardsville. They would not give Shannon an offer at all, so that quickly became a no-go. So like, it sounds crazy, but academia is, in some sense, the hardest job path to go down. If that's what you're interested in. And it also requires sacrifices of like, yeah, you'll be doing a postdoc, whereas Javier has made a lot more money than I have. And that's just one of the facts of he works in industry, and that's just that just comes with the territory. So like when I was also looking at other opportunities, I was applying to industrial positions with stock options in startups and all these other fun things. And yeah, the compensation's better than what you'd find in a national lab or academia. All right, Stephen, sorry, I've monopolized too much time.
No. Excellent. Okay, so my name is Stephen. So I was a graduate student at the EMAS lab from 2011 to 2017, and then I stayed in the group for another, I think, 8 months to kind of transition, just finish up some work, and also preparing application for postdoc. And after that, I joined Grant Jensen's lab at Caltech to do electron cryotomography. And earlier last year, January 2020, I joined a startup called QSimulate in the Boston area to do computational drug screening, which is kind of my current position. Although technically I'm not actually working because it's in a visa application situation because of work authorization. But yeah, but that's where I am right now. Yeah.
So let me ask you a different question, I think, and again, and many of you should feel free. So in terms of the techniques you learned in the lab, which ones were good for your current job, Stephen? And then Javier, you can also let us know. You mentioned already machine learning, which is not something you learned in the lab, you learned it by yourself later. But was there any techniques that you think for people who might be interested in going into industry would be better to invest in and learn and master?
Yeah, I mean, one of the things that I think is very valuable because it's very flexible is coding. So try to learn Python. Actually, just Python is pretty much all you need. That's one thing. And then if you want to go into like pharma or drug discovery business, structure-based techniques, companies now have a lot of computer power. So they're doing a lot of crazy things with all these techniques that we were talking about before, replica exchange, free energy calculations, things like that.
I see.
So there is actually a lot of need for that kind of expertise. It's growing. I mean, the classical technique was docking, but now it's moving way ahead of that, and it's a combination of a lot of things. And machine learning and structure-based techniques, I think, free energy calculations and things like that. But yeah, coding is vital. I think is the best thing you can learn. Yeah.
I see. Absolutely. Stephen, do you have something to add?
Yes. So I think I'm actually not the best example because I went through a postdoc period instead of directly applying for industry. So that actually, I think, and also, there's some kind of a difference in terms of what they did as a grad student and also as a postdoc. So, but what I found that most helpful in terms of applying for, say, in the pharmaceutical industry is that, as Javier mentioned, that you do need to know a lot of practical things like docking, which because like in the industry, they care about efficiency, care about speed. So usually they don't actually do hundreds of nanoseconds simulation to find out whether a particular drug binds or is effective or not. Usually they try to screen probably millions of compounds and then find something that experimentalists can work with. So in terms of something useful, I think the most useful thing is that you have demonstrated experience in MD simulation. I think that's what they look for at the first glance, on the first sight. In terms of other things, technical skills, I think definitely free energy calculations, especially FEP. And this is almost considered as the gold standard for like high precision drug discovery. You need to be able to put that on your CV or resume. And then practical skills, Harry mentioned about coding with Python, definitely. Python is probably people would almost expect you to know, because there are a lot of scripting involved, and many things that used in the industry, they actually implemented in Python, not anything else. In terms of simulation software, I would say it's good if you can get to learn Amber rather than NAMD. I'm not saying anything bad about NAMD, mostly because licensing issue. Although we think that NAMD is free and we're free to use, but technically speaking, if you look at the license agreement, a NAMD is not actually free for industry, or at least not as it is. So like, for example, my current employer, QSimulate, they consider it and then they drop, because even they consider if they actually want to make an inquiry, because it's quite ambiguous, the legal terms of NAMD license. My lawyer thought, even if I make an inquiry by the industry, lawyers, even talking to lawyers like $1,000 per hour. So that is just like extra cost that for small startups is just inhibiting factors. And Amber is, although it technically has a fee, but for the GPU part, but the CPU code is free and is open source. It's kind of the standard open source license, which means that there's no legal issue, that everything is understood. Wow. So yes, so that's just one thing I was pretty surprised, and which is also frustrating last year, because I couldn't use anything I learned from the group.
Yeah, I know. And David, we should look into this and see what is it that's freaking out the industry about.
It's the license is poorly worded. That's
yeah. I mean,
the problem.
The license is great for academics and government labs, because government labs don't care. We're the U.S. government and we paid for it. But for commercial entities, the NAMD license, even the VMD license, is a little fuzzy.
Well, it reads weird because the terminology is not the way they would expect the terminology to be, to give them, the freedom to actually use it, without paying for it. So, yeah.
I mean, I remember at the first company I actually wrote an email to John asking him if we had to pay him for using NAMD or no, VMD, because I think the VMD license is also kind of, I don't remember which one, but I asked an email asking, he said, no, it's fine.
Yeah, I mean, it's similar. And yeah, the problem is just the way that the licensing is, the license is phrased, that,
now that you guys mention it, I remember that we do receive quite a few emails from industry about, oh, is NAMD really free for industry? And I was always wondering why they're asking this. Isn't it free? I mean, don't we say it's free? Why do you need to ask? And now I understand actually that things are ambiguous and vague, maybe. Okay, good to know. But I don't want to actually go on the NAMD licensing kind of track. So let me actually, again, I think I'm asking all the questions. Please, guys. Oh, Nandan.
I have a question to actually Jing and Josh about pursuing a postdoc. So if you want to, in the future, be in the academia and you want to do a postdoc after your graduation, so how important it is that you go to a well-known established PI or a new PI where you can learn, like maybe you can learn more in the Indian UPI, and maybe if you go to, I'm just asking this frankly.
So we both have invested interests in telling you should go to new PIs. But like, I mean, the most important part for you is, where am I going to be the most productive, right? So my postdoctoral mentors were great, but they basically let me do what I wanted. And so like for you as a postdoc, if you want to become a professor, you need to be able to demonstrate, I can get my own funding, I can independently think about my research, and I'm not a complete pain in the butt to work with for like other people. So what that means is publish papers, participate in the grant writing process and have some collaborations for us. That means have some collaborations with experimental groups so that you know that you can work well with others, or that you can demonstrate that you can work well with others. Whether that means that you go to a new PI or an established PI, I think Jing and I both went to fairly established people. In part, that's just a matter of like who we knew. But I hired new postdocs, and they are coming here, and I hope to have a great experience for them. Hi, Martin. I think you're still here around somewhere. And I didn't see Saad, but that's okay. Jing, do you have any thoughts?
I think either way. I mean, if you can join a established lab, it means you might have much more collaboration opportunities. You might have much better, high impact publications. That's pretty good for you future in academia. As Emma just mentioned, publication is very important, right? But another thing is if there's a new faculty who is working in a very new area, but it's very promising, and you want to learn that techniques to add one more, at least one more tool in your toolkit, that might be also a good investment for your postdoc session. So I think it's highly dependent on the situation. Either way might work, but it's just dependent on the situation. Yeah.
I mean, so like in general, as a new PI, we are much easier to talk to than a more established PI is. I'm not going to name any names here, but let's just say that you needed to find the big boss. That's sometimes a little bit more difficult than slacking me and just saying, hey, we need to talk, and I am there in about half an hour. So it's just a very different kind of environment. It's not that one's necessarily better or worse, it's that they're different, and you need to know that difference going in.
Yeah. So was there anything, again, a general question I want to bring up is, and Nanda, you can actually ask follow-up questions. So a general question, I would like to know what were other things, other skills that you felt you were missing? Let's say, for example, oh, I wish I had done this when I was a graduate student. I wish I had learned this. I don't know. We write papers, of course, we write proposals. We do other things in the lab that are beyond just doing science and doing research. So is there anything that you want to highlight as, oh, this was really, really helpful, or actually I missed this particular aspect, I didn't get trained for it in the lab, and I realized later that this would have been really helpful to me? What do you guys think? Do you have any comments?
I want comment, but it's not really about a skill. It's more like an opportunity. I think internships, well, if you're thinking of going into industry, I didn't do any. And I think some people in this call did a couple and are doing a couple maybe. But I think Jing mentioned that academia is getting very competitive, or it is very competitive. Industry, it's about the same in terms of competition, or it's getting harder because undergrads are very well prepared right now. Like they probably have a lot of skills that grad students don't have yet, and in terms of soft skills and also technical skills, just because of internships. So I think that's a key thing to get going. I don't know exactly how the process is from grad school, because I know that industry is interested in recruiting people all the time. So if you see an email from someone saying like, we're interested in some of your students or something, that's something that will be very helpful in the long term.
Absolutely. I wasn't very proactive in the beginning when we started the group, but over the last few years, I've been constantly encouraging everybody to apply for internships, because we are seeing the result of it. Yep. And we have been also trying to establish as much connection as we can people like yourself, for example, to ask for people. I mean, if there are opportunities, let us know and forward these things to students. That's a very, very important point. I see actually Miranal is also joining us as a former group member who is in industry. So now we have an extended panel actually. Miranal, do you want to say a few words about yourself?
Hi, so I was a grad student in the lab from 2012 till I think 2018, and then I did a small postdoc at AstraZeneca. I think stayed there for 4 or 5 months only. I didn't like it, and then I moved to Broad Institute, and right now I'm a computational chemist within the drug discovery wing of the Broad Institute. So I'm like semi between academia and industry. So I'm not completely industry. So I'm within like the commercial wing of the Broad Institute. So
okay,
yeah, so it's like I'm still in between, not 100% industry.
okay,
Yeah.
okay, cool. Okay, Shashank.
Yeah, I have a question more specifically for Javier and Steven, and the question is more along the lines of like a working environment or working culture or differences between a startup environment and a big pharma kind of.
However you want to start?
Yeah, I can tell you a little bit of that. So I started at a mid-sized company. I think we were about 100 people, and it was pretty nice. The environment was pretty nice. It's a little fast-paced, but not super fast-paced. And then the second place I was at was smaller and definitely more challenging in terms of the working culture. It was a smaller company, I think probably 50, 20, 30, 50 people, something like that. It was more challenging and at times a little bit toxic, but that was just because the management did everything wrong that they could do. And now that I'm in a really big company, everything is very smooth. Everybody, it's you have goals and you have objectives and things like that, but it's pretty relaxed in terms of the work-life balance and things like that. They respect that a lot and actually they encourage you to not. That's one of the first things they tell you: don't overwork because we're not paying you for that overtime you're doing. So just pay, your 8 hours a day. So yeah, startups I think are pretty. I like to say dynamic. Everything is pretty fast-paced. It's bigger companies are definitely slower, but I think also very challenging. It's intellectually challenging. So, yeah.
I mean, so one of the things that like the national labs kind of pretend to be run as a business, and one of the things that really made me realize that, oh yeah, that's why the parking lot empties at 5 o'clock is you have to fill out timesheets. And so like you have to say, I spent 4 hours today working on this project and 4 hours today working on this project, or however you split it up. So like, unlike in academia where you're never really not working, the line is much stronger the closer you get to industry.
Okay, so I can only speak from my past year's experience. So we are actually a very tiny startup, and only about 10 people each. So usually I think the intensity is quite high. Actually, I would say probably even higher than I was a graduate student. And that's, I would say, I don't know about whether it's in general or not, but what I heard is that like usually in startups, you are kind of expected to work more and longer hours than bigger companies. So that's almost, I mean, that's my experience at least in the past year. And the good thing is that you do actually have more control. And because usually for startups, there's like in my case, there's almost nothing when I started. Like everything literally starting from scratch, and I got to build the first protocol that's make it work. So you do actually feel more accomplished in that kind of small environment, but you do actually spend a lot more hours, perhaps compared to bigger companies.
So I see we have a question that came in via the chat. So how does the research areas during PhD and postdoc matter for an academic position? Like working in different projects is more important, or working consistently in a specific field is more important? Jing, do you want to start?
Yeah, okay. I can say something about this question. For example, for me, I was working in membrane transporters for my PhD degree study. During my postdoc session, I was working in ion channel. Actually, there's no big difference between membrane transporters and ion channels. So, so basically, both of them are membrane proteins responsible for the membrane transport. And when I was in UI, I was working by applying the MD simulations in my research. After I moved to Chicago, I was still using MD simulations, maybe more free energy calculations, but it's not big difference. So you see, I still got a position in academia. So there's no hurt if you still working in the same area by using similar techniques. But I still highly recommend you to consider to change something for you postdoc session, like a different, definitely a different research project. And if you can learn some new techniques, that would be very helpful for you to apply positions in academia in the future. So it doesn't hurt, but I still highly recommend you to consider to change, to have something more, in the postdoc session.
Like Jing brings up a very common piece of advice. Like your postdoc should either teach you something new by technique or problem or project or whatever. Like something has to be different, because you have to grow as a scientist and not do the same kinds of things that you were doing as a PhD student. So I kind of had the opposite experience of Jing. Like my PhD work was all in membrane associated things, with like a couple of things that I worked at the national labs for. That little part of my PhD grew into a much bigger part of my postdoc. Like I was still doing some membrane kinds of simulations, and it's still all simulations with NAMD or CHARM or AMBER or whatever. But the problems I was attacking were not based on health, they were based on energy. And what this meant for me was I could plausibly apply to a lot more positions. So if I saw something in physics that called for one kind of scientist, I can be like, oh yeah, I did that. If I saw something in chemistry, oh yeah, I did that too. Oh yeah, I did this, and I did all these things, and it all comes together of like, yes, I'm attacking these things computationally. And it meant that I could apply to 80 things more easily than if I only had, I have been studying the XYZ enzyme of Drosophila since time immemorial. Like you can't be too specialized, because they have to be looking for exactly that thing if you are overly specialized. So like, again, Jing points out, like, yeah, the same broad brushstrokes of protein in a membrane, that's what I studied in my PhD, my postdoc, but that's a big enough pool of things that you can do a lot of work. So you don't want to you just don't want to over specialize into protein XYZ, if that makes sense.
Yeah, sure. I agree with Josh. Even for my situation right now, I'm still working in the ion channel area. Now I just switched from potassium channel to sodium channel, and I use the sodium channel to write my proposals. So because you have been in this area for like over 10 years, so you know those questions in depth, that would be helpful for you to apply grant in the future. That's definitely very helpful. But as Emma just mentioned, what you really wish you had learned before. I mean, for me, I wish I learned more like machine learning techniques or bioinformatics during my postdoc session. That means now when I establish my own lab, I can have much more approaches to attack more, interesting questions, and to have more opportunities for my grant applications. So this is another consideration.
Can I ask one question along the same line? So I have, as far as I have seen, like some people in their postdoc do application and some people do in the method development side. And does it matter in terms of when you apply for a PI position? Like does it make any difference? Like a person who did some method development or person who is purely in the application side, does it make any difference, or it's?
Yes. So the folks that tend to, so if you work in method development, the folks I am most familiar with end up working for national labs or hardware vendors. So there are relatively few folks that do method development, especially in simulation, and end up getting hired somewhere. Like most folks that I am aware of do method development plus other things. And they're primarily hired by the other things part, because like, if you think about it, if you're in front of a hiring committee, or that the hiring committee has to make their decision, they may not appreciate the value of this new method that you have developed. And it might be the best thing since sliced bread, but they don't understand it. But they understand the scientific questions that you're trying to address with this new method, and then you can get hired. So like when I was at Oak Ridge, there are very talented people that spent their postdocs doing method development. And they are now computational scientists at Oak Ridge, supporting users on the machine for that method that they have developed, or other things that they are that they are uniquely attuned to, because they know like the hardware, software development kinds of things a lot better than the here's how I build a grant to fund a group and go forward.
I have a question related to what we were talking about, partially directed to Josh, but anyone can talk to. I know, Josh, you had contacts with the hardware vendors, NVIDIA, AMD, and those I'm aware of. So have you tried to get a position in these hardware vendors companies, or you were interested more in academia, scientific thing?
I mean, so when I was thinking about what I wanted to do after my postdoc, I applied pretty broadly. One of the places that I interviewed at and gave me a position or offered me a position is Rescale. So they were like a cloud computing kind of platform. And when I was interviewing there and realizing what it meant day to day as to what your job is, I realized I would have absolutely no time to do my own research or play around and do things that I thought were cool. And so to me, it was worth the lower salary to go work somewhere where I could do cool things on my own time a little bit more. And that's why I ended up where I ended up. But if you wanted to work at NVIDIA or AMD, and you had the software chops to back it up, I mean, I know that, I mean, NVIDIA especially, but also AMD, they need folks to code monkey GPUs so that they can sell more GPUs. As someone who spent a chunk of their startup on buying nodes, I was like, yeah, I need some GPUs because I have GROMACS, NAMD, Amber, all these tools that use them. And there are still a large fraction of the scientific academic code base that only kind of sort of works on GPUs, and that would be a kind of thing that you would have to be able to do if you wanted to work, especially for a hardware vendor. But like if on the software side of things, like you have examples like Stephen or Javier that sort of moved in that direction.
Thanks.
I have a question particularly for Josh, because you have worked in both national lab and also in academia. So I want to know that, like, what is the difference in terms of the job prospects and also the like academic, like the job positions there? Like, because when I look at the like the job positions in national labs, I see like different kinds of computational scientists. Somebody is like a senior scientist. It's difficult to understand that who is a postdoc and who is like a PI level position or something like that. So this hierarchy is kind of difficult for me to follow. Like, can you give some idea on that?
Okay, so unfortunately, especially in the national labs, it depends on what lab you're in. So there are like levels. It's really weird. So if I had stayed on at NREL as a research person, I would have been a researcher 3, which is higher than a researcher 1 or 2. So a researcher 1 is a researcher that only has a bachelor's. There are very few of these. There's a researcher 2, they only have a master's basically, or master's equivalent training. Researcher 3 is, these are the people with PhDs who we like and have had a postdoc. And then 4 are senior scientists, 5s are like internationally known scientists. And there are like a handful of, these people can do whatever they want because they are that good. For, at least in the national labs, postdocs are called postdocs. And if they have a scientist in the title, they are a staff scientist. Does that clarify at all?
Yeah, it helps a bit. So does that mean that staff scientists means they are somewhat like a PI in a university, like they are advising students or something like that?
So it doesn't necessarily mean that they're advising students. It means that they have like a similar job description. So a researcher 3 is like an assistant professor. A researcher 4 is like an associate professor. A researcher 5 is like a professor. The job description is different, but the funding acquisition elements are kind of the same. So like at a national lab, you have to write grants to fund yourself and your research group if you have one. So like you have to pay for your time, and at a national lab especially, that's kind of hard because the overhead rate is 300% or something egregious. So like you have to bring in $400,000 a year to pay for yourself, who only sees maybe a quarter of that money, right? So my advice is try and find yourself a postdoc at a national lab. They will tend to be, like, there are many more postdocs positions that are openly posted than there are staff scientist positions, because those staff scientist positions tend to be made or tend to be offered with someone already in mind. That also gets you in the door, especially if you haven't had any experiences working in the national labs before, of what it's like to work in a national lab, because it's not for everybody. Like if you work at one of the weapons labs, you have to pass background checks and you have to be okay working adjacent to classified things. And that's not for everybody. So postdocs, I highly recommend. They have competitive ones that I also highly recommend because they pay better. And in general, even non-special postdocs at national labs pay better than academic postdocs do, because the standards of the expectations are higher.
Mm-hmm. Thank you.
Okay. Yep. Great. I'm learning a lot myself, actually. This is very, very helpful. So any other questions? We are almost reaching actually 5 o'clock this time. I know this might be a good time to adjourn. So I guess, I mean, I hope that you guys don't mind to be contacted if there are other specific questions. So I think our friends and colleagues would be happy to address any additional questions that you guys might have. And I think this was very, very useful. We should do it, I think, once or twice a year, maybe inviting different groups of former group members or otherwise from different people to have this. This was actually a second kind of career-oriented gathering or webinar or event But the first one was not as good as this one, I would say. So I think instead of the sense of friendship, people feel free to ask questions and chat. And the fact we have actually multiple of you guys on the panel really made a difference this time.
Yeah, I mean, so like, again, I think I can speak for all of us. I know Javier had to go because he has to go home at some point.
Yeah.
It's we've all been in your shoes at one point or another in our lives. Like we've been there. We understand what it's like. And these are some of the paths that we have taken through our careers to see what it is. Because I definitely remember when I was in your shoes of like, I don't know what I'm going to do in 5 years. Don't ask me that question. I can't tell you. I distinctly remember having a conversation with Ahmad. I will never be a professor.
Yeah, I remember you were in my office telling me that.
So like, don't hesitate to reach out. We're there. We want to help. We're just oftentimes busy, and sometimes we may not respond right away. That's okay.
Okay, great. It's really nice to see you all, by the way. Mirinal, Jing, Steven, Josh, of course, Javier, who is no longer here. I was really, really happy to see you all and finding out a little bit more about what you're doing now, actually. Hopefully you're staying safe. Thanks again for making the time and being with us and answering some questions. And let us know actually if there are opportunities for students, postdocs, especially people in industry, but also in academia. Let us know. I mean, I think our network is growing larger and larger, former group members, and we are establishing more connections and collaborations with different institutions, with different companies actually. So it would be nice to expand our network. And I think I'm gonna encourage everybody to sign up for LinkedIn and make sure they have an active account there. Good, thank you again. Thanks again for all your time. It was really great.
Thank you, Matt.
Bye.
Yeah.
Thanks, Eva.
Bye.